natural gate. That activates a subsidiary redundant circuit. So we've got populations of neurons that fire in synchrony to music, that entrain to the music and predict where the next beat's going to be.
Right.
And that allows Parkinson's patients to walk smoothly. There's a technique called rhythmic auditory stimulation developed by a colleague of mine named Michael Tout at University of Toronto. He was at Colorado State when he developed it.
And let me guess, that's where you play the Bee Gees. You can tell by the way I use my walk.
That's exactly right. Or any music by NSYNC. You play the music at the right tempo, and the neurons start firing, and they can maintain a steady gait. And after a course of this therapy, some Parkinson's patients are able to get rid of their crutches and walkers and walk for months.
Whoa.
How does memory work? Like, if I took a snapshot as a physicist and I come to your brain and I just look at the state of every neuron, am I going to know what memories lurk hidden within your neurochemistry?
Right. So this is the idea of the connectome, which Sebastian Sung at Princeton and others have been working on.
That's a recent term, right?
Yes.
The connectome, yes.
And the idea is it's parallel to the genome. It's not enough to know where all the neurons are or what they do. You have to know how they connect to one another and what state they're in at any given time.
So what is it about the state of your neurons that preserves a memory?
So here's what we think. I mean, this is speculation. When you experience something, for example, you're looking at a sunset, you're listening to music, you're drinking a nice glass of red wine, that's an experience, and the experience is delivered to you, beginning with some stimulation impinging on your sensory receptors, setting off a cascade of neurochemical, neuroelectrical activity. And so there's some group of neurons that are delivering that experience. If it's wine, that's the taste buds and your olfactory system and the olfactory bulb, and it presents it to somewhere in your brain that has self-consciousness and awareness in the prefrontal cortex of what's happening. If you were to later remember that experience, as I say, my lab and other labs have shown that it's the same neural family, the same group of neurons, the same pattern that are activated in the memory. So what allows you to distinguish a memory from an actual event? It appears, we think, there are neurochemical tags that get attached to an event when it gets stored in memory, so that when you pull it out, you know that it's a memory and not an actual event. This is evolutionarily very important because same thing happens when you dream. There are neurochemical tags that say this is a dream, because otherwise I might dream